We're going to explain segmentation faults, specifically segmentation fault 11, in Python. A segmentation fault, often shown as segmentation fault, core dumped, or segmentation fault 11, is a serious error, indicating your program tried to access memory it shouldn't have. Think of it like trying to open a door that doesn't exist in a building. The system stops you because it's unsafe. In Python, this is less common than in languages like C or C++, because Python has a garbage collector and memory management built in, but it can still happen. 1. Causes of segmentation faults in Python. The most frequent cause is interacting with C extensions or libraries. If a C extension has a bug leading to memory corruption, overwriting memory it shouldn't, accessing invalid memory addresses, a segmentation fault can occur. Another cause is using low-level memory manipulation techniques within Python, though less likely due to Python's higher-level nature. Proper use of NumPy arrays, particularly out-of-bounds indexing, trying to access an element beyond the array's size, or referencing a deallocated NumPy array are common culprits. Finally, running out of memory, although this might not always show up as a segmentation fault, but as a memory error. 2. Debugging segmentation faults. Unfortunately, pinpointing the exact location in your Python code responsible for a segmentation fault isn't always straightforward. Python's error messages might not pinpoint the exact line in your code, especially if the problem originated in a C extension. Here's how you can try. A. Check your C extensions. If you're using any C extensions, thoroughly review their code for memory management errors. Look for potential buffer overflows or attempts to access memory after it has been freed. Check the documentation for potential issues, and if you have the source, debugging with a C debugger, like GDB, will likely be necessary. D. Examine NumPy usage. Pay close attention to array indexing. Make sure you are not trying to access elements outside the bounds of your NumPy arrays. Print array shapes and indices to check if the calculation of your array indices is correct. C. Simplify your code. If you have a large, complex program, start by commenting out sections to isolate the problem area. Try running smaller, self-contained code sections to see if the error persists. This will help narrow down the source of the problem. Use a debugger. Even though the segmentation fault happens at the C system level, debuggers may help you identify the lines of code in your Python program that lead to the error. A Python debugger like PDB can help you step through your code and monitor variables to observe the flow of execution and identify the source of errors. 3. Preventing segmentation faults. The best approach is to prevent them. Use Python's built-in features whenever possible, instead of resorting to low-level memory handling. Check array bounds rigorously when working with NumPy. Employ defensive programming practices, such as checking for none values before attempting to access their attributes. Always use updated and well-tested libraries to reduce the chance of encountering errors in their C extensions. Also be mindful of your program's memory consumption, and consider better memory management if necessary to prevent running out of memory. If possible, use a memory profiler. Remember, resolving segmentation faults often requires careful debugging and a good understanding of how your code interacts with memory. If you are using a third-party library, it could be the cause and you might need to report the issue to that library's maintainer.